Hi everyone, hopefully you can all hear me. Sounds good. Awesome. As Aparna said, my name's Alex and I'm team leader here at Bloomberg for the cross commodities team. We're responsible for discoverability of commodities and run both a front-end Python stack as well as a RabbitMQ Python pipeline in the background as well. And I've recently come across GraphQL. And I want to talk about my journey of learning about GraphQL and trying to inspire more of you to go out, find out about it, because I think it's a really cool technology. And this presentation is really given from the point of view of an enthusiastic beginner. I've written a couple of example script servers, try to get to know it. I'm currently writing a proof of concept internally as well before trying to persuade the rest of my team to use it. So hopefully today I can inspire you to go and learn a little bit more about it. The slides are all online, the example code's online as well, and I'll tweet about it later at Alex Chamberlain as well. So as I said, I'm really looking to inspire you to write some GraphQL servers in Python and signpost you towards some fantastic open source libraries that are available now for you to use. So GraphQL is an API technology that's come out of Facebook. I'm not going to read the definition to you there. It's available on graphql.org. But essentially, GraphQL comes in two parts. A schema definition language that defines the contract between your client and your server. I am going to talk about that quite a lot because I think it's quite important. And a query language for actually defining what you want as a client from the server. So you can kind of think of the query language as your SQL data manipulation type stuff and your schema language in a similar way to your data definition language in SQL. They're kind of comparable. So this is an example query. You'll notice that you can name queries. In this case, it's named country there. You have operations on which that you want to call, so we're calling the country API. You have arguments that are always keyword arguments that are always specified by name. And in this case, we're passing in the string US. That's a 2-character ISO code there. And then what makes GraphQL different from most of the query languages out there is you then tell the server, hey, as a client, for my use case, I need these fields returned. So in this case, I need ISO code, name, and a list of cities that belong to this country. And I'm going to keep reusing this example throughout the presentation. So I'll refer to city API. It's just a sort of basic idea. You can kind of imagine that it exposes accesses for city objects, for country objects, and the links between them, because it's a good use case for GraphQL. This is another example, just to point out a couple of the other features that you can have. In this case, you can see that arguments can support many different types. In the first case, we used a string argument. In this case, we're using an integer. You can have aliases for any field. So in this case, the first query is alias to London, the second query to New York. And that's supported throughout the query. So if I wanted to rename name as label or something to that effect, prefixing it with that alias would work. And each key has to be unique, which sometimes makes aliasing necessary. The arguments can also be complex types. They're called input types if you want to go and look them up. But I won't really be talking about them too much today. So the GraphQL basics. As I said, GraphQL really starts with a schema definition language. This is where you define what types your schema use. And GraphQL is really built around its type system. Type system is quite powerful. And I'll show you an example of the schema in a bit. The schema defines your contract between your client and your server. And I think this is a really important thing, and it's very important for schema-driven or schema-first design, where you sit down and you define your schema. That's not to say that you never change it again. Schemas obviously evolve as the use cases evolve. But it's really useful methodology to get yourself into about thinking about, okay, so I've got my server. What's my interface to my server? And I think that's a really massive benefit We've been using schema-first design here at Bloomberg for quite a while, and I must say it really does speed up development. You have your basic root types. These are the basic operations that a GraphQL server can support. Read-only operations such as the queries, read-write operations in the mutation, and there is now getting some basic support around subscriptions as well. So that's where basically it's a kind of pub-sub mechanism. Typically, but not absolutely necessary for GraphQL, the query and mutations would be served over HTTP. The vast majority of examples out there are going to be HTTP based, and the subscription would be over WebSockets. But the actual GraphQL spec doesn't really talk about transport. The transport is really a convention that's built up over time. So if you have a different request response protocol that you use at your corporation, GraphQL still works. If you have a different pub sub or you want to publish your pub sub over Rabbit or over Kafka, that still works too. One other really important thing that I'm going to talk about is resolvers. So whilst the spec, again, doesn't actually specify how you go about implementing your server could just be serving up static files for all the spec cares about. And in mock servers, that probably is what you're actually going to do. But most implementations out there use a resolver pattern where a function or a resolver is called for each field. And I think it's quite important to understand those resolvers. So this is a little bit Python specific, but the JavaScript examples and most other examples have very similar patterns as well. A GraphQL resolver is just a function. It typically takes two positional arguments. The source, that's the object that this field is being resolved for. So at the top, that's probably going to be none. Okay, you're just saying, I want to call this city API at the root level. But as you go down your tree, as you go into the fields on the city type or on the country type, that's going to become a sort of real object that you might want to reference. The resolve info, which has loads of information, most of which you'll never use in a typical use case, but it provides a space where you can share information across your resolvers. So that's your context, if you like. And in the example code, we share our database connection via the context mechanism. And the field name, which is really useful, as I'll show you in a second, for the default resolver. The arguments from the client get passed in as keyword arguments. These are already being validated. They're already of the correct type. So you can trust that. That comes from the libraries for free. And it'll be according to the schema as well. And then your response to your client comes in the form of the result. So at a high level, that might be a value semantic object, an object you're returning to the client, or it could be a scalar type, either one of the native ones supported, like string, float, int, that type of thing, or a scalar type that you've defined. So one of the schemas I've worked on recently, we defined a UUID or GUID scalar object, because a lot of our IDs took that form. And then resolvers kind of recurse into themselves. So the first resolver you get called might return a city object, the whole object that represents the city row in the database. Whereas when you're populating the name field on that city object, the source becomes that city object, it recurses into that. And then you return a scalar value from that, presumably a string for the name. And of course, at the lowest level, most of the resolvers actually look exactly the same. You know, you've gone to your database, you've constructed your city object, you've constructed your country object, and you just want to return the value that's on that attribute. And so the default resolver provides that for you. But the reason I've copied it here is it provides a nice illustration of some of the things you can do with the resolve info. So resolve info, you can access the field name. So if you want the same resolver across multiple field names and they might maybe have a slightly different implementation, that information is available for you. It also shows that the default resolver in the Python stack uses attribute notation or dot notation. There's no good returning a dictionary. The default resolver is not going to work for you. You need to use first class objects or override the default resolver. That took me a couple of minutes to figure out the first time. So let's move on to the pros and cons. So this isn't necessarily Python specific at this point, but Of course, when you're trying to sell a new idea to a bunch of engineers, what do they first do? And they go, oh, you know, that might work for 95% of our use cases, but it doesn't work for the other 5%, so we can't use it. So they're going to list all the cons off for you first. So these are a few of the cons that I could think of. And of course, we're at a Python conference, and the first thing I've noticed about the GraphQL ecosystem, it's largely JavaScript. You Google GraphQL, most of your examples are going to be JavaScript. Most of the tutorials are in JavaScript. Most of the clients are in JavaScript. Now, that's great if you're a web developer. But if you're trying to apply it to other technologies, that may feel a little bit alienating to start with. But I'd like to start by reassuring you that the ecosystems in the other languages are equally thriving as well. It just started in the JavaScript space. And the other pet peeve of mine, I told you I'd mention the schema quite a lot, is many examples conflate the schema with the business logic. So they might define the schema in code rather than using the schema definition language. And that makes it really hard if you're the other side of the coin. So if you're the server developer, fine, I don't have to define my schema twice. I just do it in code, and when I add a new attribute, it just magically appears in the schema. But imagine that you're the client. How do I go and find the schema? Well, wait, I have to connect to your server, download the schema, decode the schema into the schema definition language, and read it. That's really difficult. So by providing the schema up front, you're doing two things. You're agreeing that contract with the client, and you're providing them with the service that they deserve. You're providing them with that documentation that they need as your client. Why should we use GraphQL? Well, it's slowly becoming an industry standard. I went onto the GraphQL website to do a little bit of research for this, and they actually list off a variety of companies using it. So it started at Facebook, but GitHub has a GraphQL API as well. Pinterest, Intuit, Coursera, and Shopify are also using it as well. And hopefully one day I'll add Bloomberg to that list. There are conferences around for GraphQL. The GraphQL Europe conference is actually in a few weeks' time. Unfortunately, I can't make it. Meteor provide consultancy services around their Apollo ecosystem. And there's even a back-end as a service called GraphQL. That was such a cool name. They've recently changed it to Prisma as well. Providing, as I said, a back-end as a service. So you don't even have to run your own infrastructure if you don't want to. There's a strongly typed schema. One of the big criticisms that REST APIs often get is like, what objects am I going to get back? Oh, just query the API and see what you get. Well, that's kind of not good enough, to be honest. The strongly typed schema gives you those guarantees that you need. No more over or under fetching. Again, one of the big criticisms of microservices is, well, because this service has to be reused across a lot of clients, you either give me too much data, i.e. over-fetching. That could be slow, it could use up the bandwidth, it could expose data that that client just doesn't need, which in sort of GDPR terms is a really bad thing. Or it could not give you enough data, i.e. underfetching. So this is a typical problem where you get a list of IDs back, and for each ID you have to go and make another API request, i.e. the n+1 problem. GraphQL solves this by saying, hey, tell me what information you need up front. If you need the cities that belong to a country, tell me that, and tell me the information you need on those cities, and I'll give it back to you in one go. Now, the server might have to make loads more queries to the database to do that, but at least it's all contained in one place, and if it proves costly enough, the back-end engineers can optimize it. I hope so. Rapid product development. So the rapid product development, again, comes from this schema. The schema's agreed up front. The clients can go away and say, look, let me bring up a mock server with fixed results just so I can get the client going while you bring up the real server behind it. And the back-end engineers can go away, write the server. Now, of course, those two engineers might be the same person in some cases, but it really decouples your development from your client and your back-end. It's composable. This is a relatively new idea, but if you've got the same entity represented in two GraphQL schemas, rather than the client having to go to both entities, say to go to one API to get the number of car parking spaces currently available in a city, and the other API to find out the location of the city, you might provide a composed or a merged layer in front of it, and dynamically dispatch the request to those to schemas themselves. And finally, there's a rich ecosystem. I am going to have to look at my notes for this one. So server libraries are available in C#, Clojure, Elixir, Erlang, Go, Groovy, Java, PHP, Scala, and Ruby. Not to mention the fact that it all started in JavaScript, and there is a rich Node ecosystem out there. And of course, there's a great Python ecosystem too. So the Python support is generally around 23 repositories on the GraphQL Python organization on GitHub. I haven't actually had a chance to send a pull request their way yet, unfortunately. And the main implementation, the query parsing, the schema definition parsing, is all done in GraphQL core. And then there's loads of satellite libraries around it that implements various things, such as integration with common frameworks. So the example I'll be showing today is an asynchronous one based on Sonic GraphQL. But I know that there was a Django workshop yesterday, and there's a Graphene Django integration layer as well, that maybe you could go away and put a GraphQL API on the front of that website you developed yesterday. Another library that I'm going to show you is called AIO Data Loader. And this is an asynchronous library. It's not specific to GraphQL, but it allows you to separate the data fetching layer from everything else in your application. The API it exposes is a load API. You say cityloader.load and then provide the name of the city or whatever you want to load. And behind the scenes, it will batch up a bunch of these calls together. And as an implementer, you implement the batch load function. So as I said, the illustrative example I'm just going to go quickly over is that of a city API. Make up the requirements in your head. There are city objects, there are country objects, there's links between them. They have some parameters. All the data is Creative Commons from the GeoNames database. So what does the schema look like? Well, it's fairly simple. You start by defining what your types are. My country has an ISO code. It has a name. They're both strings. They're both required. That is, if the client says, hey, give me the name of this country, the API guarantees it will get one back. You can't send a null back in that case. But you only send it back if the client asks for it. The city has a similar number of attributes, and then there's these relationship fields between them. A city has a single country. A country has multiple cities, and you can see that in the list syntax. And of course, there's lots of documentation about writing schemas and the intricacies thereof. You can see the root type at the bottom, the query type, and the formal declaration of what our schema looks like. And so the schema also takes a mutation argument, a subscription argument, where you can provide those types as well. But I've just implemented a read-only service in this case. The loader, the country loader, is relatively simple. As I said, you can see the batch load function that you'll never directly call. That's called by the data loader library. And you can see the resolver underneath. I chose to do it as a member function, but it's not necessary if you don't want. And you can see the basic format of context, resolve info, and then the keyword arguments that the client provided. Then this is where we tie up the schema. So you've got your schema file. I'm going to parse it and load it. I've got rid of the intricacies of that. If you want to have a look at the code there, it's all on GitHub. Parse it, and then I've written this make executable schema utility that just connects the two together. So we've got our formal schema file. It's been carved in stone somewhere. The clients are basing their implementation on that. And then in code, we just say, hey, if you need a resolver for query country, use this resolver. You want a resolver for cities? Use this resolver, and it just connects them together. It's very simple. There are various other examples online where they're set out slightly differently, such as automatically giving you the resolvers based on a database schema and things like that. There are various ways to set this up. This is just one example. And then the server. As I said, most of the integration between the GraphQL layer and the server has actually been done for you. I'm just telling it really, hey, you can go and find your schema here. And in this case, I've used the Sonic GraphQL view to allow me to override the context. So like I said before, the database connection is shared across all of the resolvers. You don't want to open a separate database connection for every field that you want to go and grab. And so, as I said, I override the context to that effect and provide the database and the loaders at that level. So let's have a look at what it looks like. So this is a little utility called GraphQL or GraphQL. Pardon? Make it bigger. Can I make it bigger? Yes. That was lucky, wasn't it? Cool. So as you can see, I've got multiple queries here, and hopefully I've remembered to start my server. Just by hitting Command Enter, it runs the query on my back end. This is really fast iteration time. I change the server, hit Enter, and I'm testing it again. And I've got a full suite of PyTest. They're all medium tests. They're all hit the database. But you could write unit tests for it quite easily as well. In the repository for everybody to have a look at. And with that, that brings me on nicely to my conclusion. So GraphQL is a fantastic way to define a contract between different parts of your system. It could be from your front end to your back end, from the UI service to your back end services. It could be between your RabbitMQ worker and your label translation system. It's just a layer, a schema layer, an API language that you can use between different actors in your system. And the ecosystems is great in a variety of languages. So you've got clients and servers in Python, but you've got them in all of the technologies you might be using at your corporation as well. So with that, I'm going to say thank you very much. I'll be around after the talk because I think I've used the full 25 minutes. Probably going to hang out for a bit at the Bloomberg booth. If anybody wants to come and talk to me about GraphQL or about jobs at Bloomberg, I'd be happy to talk about either. Thank you.